All right, so in adding decimals, we looked at the decimal fraction form of a decimal, and this does have another application that is going to be relevant to you future teachers, and seeing things in STAR tests and things like that, your TEKS. This is the completely expanded form of a number. We looked at the expanded form. Okay, let me write. Writing and talking is not my forte. Okay, the expanded form of a number, we looked at the expanded form of whole numbers, so let's look at where the expanded form of a decimal comes from. So let's say that I have 6.54, I don't know, 72, something like that, and I want to write this in expanded form. So some of you may automatically know this is 6 times 10 to the 0 plus 0.5 plus 0.04 plus 0.007 plus 0.0002. Great. But where does that come from? So I'm going to start essentially like we did in adding the decimals by writing this as a decimal fraction. So I'm going to get 65472 over 10 to the 4th power. Now, what was the purpose of that? We know how to write, because of our place value, a whole number in its expanded form. So now I have a whole number, I'm going to write it in its expanded form. This is 0, 1, 2, 3, 4, so I get 6 times 10 to the 4th plus 5 times 10 to the 3rd plus 4 times 10 squared plus 7 times 10 to the 1st plus 2 times 10 to the 0th power. So that's the whole number written in expanded form, but I still do have all the values divided by 10 to the 4th power. So I'm going to divide each value by 10 to the 4th power. So we do need to know a little bit of our exponent rules here. We'll really just explain them. So 10 to the 4th divided by 10 to the 4th, all those cancel, so I will have 10 to the 0th power. Plus, I have 3 10s multiplied together up top, 4 on the bottom. So 3 of those will cancel out, leaving me 1 on the bottom. So I get 5 times 1 over 10. Likewise, 2 on the top, 4 on the bottom. 2 will cancel out, leaving me 2 on the bottom. So I get 4 times 1 over 10 squared. So 7 times 1 over 10 cubed plus 2 times 1 over 10 to the 4th power. So depending on grade level, you may see it like this. We can keep going, carrying on. What does 1/10, 1 over 10 squared, 1 over 10 cubed, 1 over 10 to the 4th look like? We know what 10 to the 1st, 10 squared, 10 to the 3rd, 10 to the 4th multiplied by a number tells us. If I had 4 just times 10 squared, I know that would be 4 in the hundreds place, so I would have 400. My alarm is going off. Just a moment. Okay, so what does it mean if it is in the denominator? So one thing, again using exponent rules that we can see, I can rewrite this as a whole number with a negative exponent. So 1 over 10 squared can be written with a base of 10 with a negative 2 exponent. So 1 over 10 cubed can be rewritten as 10 to the negative 3, and 1 over 10 to the 4th can be rewritten as 10 to the negative 4. So I'm going to rewrite these. 6 times, this would still stay 10 to the 0, plus 5 times 10 to the negative 1, plus 4 times 10 to the negative 2, plus 7 times 10 to the negative 3, plus 2 times 10 to the negative 4. And again, this depends on the grade level that you're teaching. Of course, if you haven't talked about negative numbers, then that would not be an appropriate form, but it does follow. So from regardless of what form you're looking at, we know that if it were 10 to the 1st, that would indicate 1 0. 10 to the negative 1 indicates 1 decimal point, right? And just by our definition of decimal fractions, this has 1 0, so 1 decimal point, 2 zeros, so 2 decimal points. So I'm going to rewrite this in their decimal form. So I get 6 times 10 to the 0 indicates no decimal points. So I'm just going to write 1, so it'll be my whole number. Plus, this indicates 1 decimal, so 5 times 0.1. plus 4 times, this is 2 decimals, so 0.01, plus 7 times 3 decimals, so 0.001, and 4 decimals, so 2 times 0.1231. There we go. And this is really about as far as we could go without multiplying each digit times its decimal form, or its decimal, how many decimal points it's going to have. So complete expanded form, and again, just depending on what grade level you're looking at, most of your STAR test questions are going to end up around here somewhere. Or even, like I said, we could take it a step further and actually multiply these, but right here, we'll stop right there. This is going to be the furthest that we can go, but this is how we get there, the expanded form.